Okay, this video goes with the 2-1 inductive reasoning that goes with our 1-4 packet, and we want to use inductive reasoning to find the next two terms in each sequence. Let's see what we got. Okay, so if we look at number 1, I can see that 4 to 8 is times 2. Well, it's either a times 2, well, it's a times 2, or it could be a plus 4. But as I go from 8 to 12, that's a plus 4. And so there's a constant difference of 4 between these terms. So if we continue that on, we're going to end up with 20 and then 24 for the other term. Let's look at number 2. Number 2, 400 to 200 is a half, to 100 is a half. So every one of these is going down by a half. So 50, 25, 12 and a half, and then 6 1/4 would be the last two terms on that one. Looking at number 3, see what we got. We got 1 over 8, 2 over 7, 1 over 2, 4 over 5. So let's see what's up with this. We got 1 out of 8, 2 out of 7. So let's look at it this way. We got 1 over 8, 2 over 7. So I'm thinking the numerators are increasing by 1 and the denominators are going down by 1. Our next one in that pattern would be 3 over 6, which is the same thing as this 1/2. And then we have 4 over 5. So we're going to have 6 over 4, which simplifies to 3/2. And then we're going to, sorry about that, we're going to have 5 over 4. And then we're going to have 6 over 3, which is the same thing as 2. So it looks like the next term is going to be 5 over 4, and then 6 over 3, which is the same thing as 2. Okay, this next one's a little bit tricky. I'm going to draw it off here to the side, and we'll check out constant differences to start with. So we have -5, 3, minus 2, 1, minus 1, 0, and we need the next 2. So looking for the first differences, there's a difference of 8 here. It looks like 8 was added to the -5 to get 3. As we go from 3 to -2, that's a subtraction of 5. As we go from -2 to 1, that's an addition of 3. As we go from 1 to -1, that's a subtraction of 2. As we go from 1 to 0, that's an addition of 1. So let's see what's going on with this pattern. I tried to do the differences down here, but this is what I noticed. 8 take away 5 gives me 3. 5 plus 3 gives me -5 plus 3 gives me -2. 3 plus -2 gives me 1. So it's almost like a Fibonacci type pattern where you're adding to the one before. So let's continue that pattern and see what we get. So 8 take away 5 is 3. -5 plus 3 is -2. 3 plus -2 is 1. -2 plus 1 is -1. And -1 plus 1 gives me 0. So that's what we get for the differences. So that means that we're going to take away 1 from 0, gives us a -1, and then we're basically going to add 0 to it. So our last two terms on this one are -1, -1. So this one was a little bit tricky. Let's see what's going on with this one. 360 down to 180 is a 1/2, but then 180 to 120 is a down by 60. And then we're going down by 30. So let's see. Okay, number 6 is also a little bit of a tricky pattern. Let's see what we got. So I'm going to do it off here to the side also. So we got 360, 180, 120, and 90. We need to find the next two. I'm thinking about I'm going down by a half of 360, takes me down to 180, taking 180 off. Then I'm going to take off half Then I'm going to take off a third of 180, which takes 60 off, so I get to 120. Then I take a fourth off of 120, which is 30, and I get to 90. Then I'm going to take a fifth off of 90, which is going to be 18. That's going to give me a 72. Then I'm going to take a sixth off of 72. A sixth of 72 is 12, and that's going to give me 60. So we end up with 72 and 60 for the last two terms. So that was also a little bit more of an advanced problem. For number 6, basically we're starting with 1 and we're multiplying by 3. So 1 times 3 gives me 3, 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81, 81 times 3 is going to be 243, and 243 times 3 is going to be 729. Okay, looking at number 7, I'm thinking, okay, like this is going up by 4, from 1 to 5 is plus 4. Then you're going up 12 as you go to 17. Then you're going up 36 as you go to 53. Then you go up 108 as you go to 161. So each one of these is increasing by a multiple of 3. So we're going to add 3 times 108, or 324, to 161. And that's going to give us 485. So we added 324. And then we're going to do 3 times 324, which is going to be like 972. And we're going to add that on to 485. Gives us a 7, carry the 1, 16. Gives us 1467. So these are a little bit more difficult problems. And let's see what's going on with this one. This is going up by 4. This is going up by 9. This is going up by 16. And this is going up by 25. So 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is going to be 36, and 7 squared is going to be 49. So 55 and 36 is going to give us 91, and 91 and 49 is going to give us 150. So that's how we would do those. Let's look at the next ones. Okay, we need to look at this next set. Looking at number 9, I'm not too sure what's going on with this pattern. Like, it looks from here to here, it flips. But this one in the middle, I'm not sure what is going to go on with that. Looks like a flip here. So this does something, and then I would imagine that on this side over here, maybe it would flip back the other way like it was before to this. But this part here, I'm not for sure. It kind of seems like it kind of rotates a little bit and then flips. Rotates a little bit. Like this is rotating this way. So rotating a little bit. Let's see. It's going to rotate. It's going to go like that. Now the dot on this one is over here. And then it flips. So I'm not so sure about number 9. If you come up with a better way, let us know. For number 10, it's kind of hard to draw these, but it looks like number-wise, we start with 1, divide it into 2 parts, then divide it into 4 parts, then it gets divided into 8 parts, So 16 parts and 32 parts is going to be the next part of the pattern. And so to do the 16 parts, we would kind of do this. And to do the 32 parts, we would do the same thing with the 16s. We would add more lines in to make it 32. So that one, I'm not so sure about drawing, but pattern-wise, we can kind of see what's going on with the numbers. Number 11 is sort of a clock arithmetic thing. It kind of threw me at first, but kind of look at it this way. We're starting at 12 o'clock. Then this looks like it's 2:40. So from 12 o'clock to 2:40, we're going to add 2 hours and 40 minutes. So we get to 2:40. Then we're going to 6:20. I realize a lot of people don't see analog clocks anymore. We're going to 6:40, and to go from 2:40 to 6:20, we're let's see, we're adding 2:40, 3:40, 4:40, 5:40, 3 hours, and another 40 minutes is going to make it to 20 after 6. So we're adding 3:40 to 2:40, and we get 6:20. Then we're going to 9 o'clock. And 9 o'clock, if we go 6:20, 7:20, 8:20, and another 40 makes 9 o'clock. So to 6:20, we're adding another 2 hours and 40 minutes. So pattern-wise, it seems like we're going to alternate between the 2:40 and the 3:40. So another 3:40 and then another 2:40 are going to give us the other times that we need. So 9 o'clock plus 3:40 is going to take us to 12:40. And 12:40 plus another 2:40, or 12:40, 1:40, 2:40, and 20 would be 3 o'clock, and another 20 left over would be to 3:20. So those are the next two patterns with these clocks. So drawing the clocks, we need to draw a 12:40. So 12:40, it's going to be a little bit after the 12, and it's going to be like over here to the 40. Something like that. And for the 3:20, we're going to have the hour hand a little bit past the 3, and the minute hand is going to be right at around the 20, something like that. So I'm calling this one 12:40. I'm calling this one 3:20. Okay, looking at the dots here, let's do this off to the side, or the points rather. So at the first one, we're starting with 3, 1. When we go to the second one, we've got -1, 3. When we go to the third one, we've got -3, -1. And we need to do 2 more. So let's see what's going on with the numbers. So we got 3, 1. The 1 becomes negative and moves to the front, and this one slides over. So this one turns negative, moves up front, this one slides over. So this one turns negative, -3, this one slides over. This one's going to turn negative, it's negative, so add a negative to it, it makes it positive. This one slides over. This one turns negative and goes over, make it +3, and this one slides over. So those are the next two in that pattern. And they want us to draw it. So one of them, we're over 1, down 3. And then the other one, we're over 3 and up 1. So that's how those patterns go. So these are the two we need to define. Let's go down a little bit more. Use inductive reasoning to test each conjecture, decide if it seems true or false. If false, give a counterexample. So let's see what we got. Every odd whole number can be written as the difference of two squares. So let's pick an odd whole number like 7 and 11. Let's see what we get. Those are odd whole numbers. So can we think of this as the difference of two squares? 7, if we do 16 take away 9, we can get 7. And that's 4 squared minus 3 squared. So that one works. To get 11 now, let's see, what could we do? 11 could be, 36 take away 25, which is 6 squared minus 5 squared. I didn't say anything about consecutive squares, but that seems to work. Let's try 7 squared minus 6 squared. See, 7 squared minus 6 squared, 49. That's not going to work. So it doesn't always work with the consecutive squares. But this seems to work. Okay, let's look at number 14. Every whole number greater than 1 can be written as a sum of two prime numbers. Now, prime numbers are numbers that are only divisible by 1 in themselves. So a partial list of prime numbers would be like 1, 2, 3, 5, 7, 11, 13, 17, 19, 23, and 24, 25, 26, 27. And it keeps on going. So let's see. Every whole number greater than 1 can be written as a sum of two prime numbers. So let's look at 15. 15 is a whole number. Can we think of it as the sum of two prime numbers? Well, it's not going to be 11 with 4, 13 and 2. Let's look at 29. 29 is another whole number. Or another... Well, okay, it's just a whole number. Let's see if we can write it as the sum of two prime numbers. 15 and 14. 17 and 12. Let's see. 17 and 12. 19 and 10. 23 and 6. 27 plus 2. And we got that one. The square of a number is larger than the number. Let's think about 1 squared. 1 squared is equal to 1. That's not larger than the number. This one's false. And this one is a yes.